Hello, this is Mr. Wyrick, and I'm here to talk to you today about Lesson 3.5. That's the fifth lesson from Chapter 3, and it's going to be about proving lines parallel. Now, the very first thing I want to talk to you about is the construction that they have at the beginning. There's a video that accompanies the textbook, so if you have access to the online version of the textbook, you can see a more in-depth way of looking at this. But basically, we construct an angle by making a couple of rays. So I'll call this point A, I'll call this point B, and then I'll call this point here C. Now I'm going to use point C to construct my parallel lines. What I do is I'll take my compass and I'll form an angle here and put lines through 2 points to this line, and then I'm going to find this exact distance here. Okay? Once I have that, I'm basically going to transpose these marks. So I transpose those marks, keeping that same distance from the first one on my, keeping the same distance from this first set of marks on my compass. And then when I find the second distance, I'm going to mark that second distance on there. Where that crosses is where I'm going to make this line here. These would be corresponding angles. Those would be parallel lines. So you can use your compass to make some parallel lines. I'll probably try to get a test for us at the end of this chapter where we'll be doing a little bit of constructing, making some parallel lines, making some perpendicular lines, and that's kind of what this one is about. When it comes to the rest of the stuff, we have the different postulates and theorems that are going to help us prove that lines are parallel. Now, we've already been working with parallel lines and saying, okay, if parallel lines exist, then these angles are congruent, these angles match up. Now we're kind of taking it and we're looking at what would be the converse of those statements. And so we're determining that the lines are parallel because the other conditions exist. Postulate 3.4 says that if our corresponding angles are congruent, then we have a set of parallel lines. So looking at this one, corresponding, and down here would be another corresponding. We should have 1, 2, 3, and 4. So we should have 4 sets of those corresponding angles. All of them should be congruent in order to prove that those lines are parallel. Again, that's the postulate. You don't really have to do a proof off that one. The theorems, and we have postulate 3.5, a line and a point that is not on that same line, there is one parallel line that goes through that point. Okay? So if I have this line here, and it is line C, D, and I have another point up here, point F, there's only one line that's going to go through point F that is going to be parallel to these. Okay? On the theorems, 3.5, 3.6, 3.7, and 3.8, basically these are going through the same things that we know to be congruent from the parallel lines that we were working with before. So if the alternate exterior angles are congruent, that's sufficient to kind of say, okay, we should probably be able to accept that these are parallel lines. If the consecutive interior angles are supplementary, if the alternate interior angles are congruent, all of these things are things that we've looked at. This last one here is a little bit simpler to visualize. If we know that we have a transversal and it's perpendicular, it makes 90-degree angles, then the fact that it forms a 90-degree angle with both of those lines means that we have parallel lines here. Okay? And again, these all kind of relate to one another. If these are perpendicular, then this would be 90 and 90, so also the consecutive interiors would add up to 180. They would be supplemental. The alternate interior angles would also be 90, so they would be congruent. So we're looking at multiple of these theorems that we can get through. But if you're just given certain bits of information, this will help you out. Tomorrow in class, we might do a quick check. So make sure you pick up a compass and go ahead and see if you can construct a pair of parallel lines. We'll see you then.